Okay, no last names today. We are live.
What are we going to do about her? Do you want this?
Oh, she has two.
Yeah.
Carly, come here.
That's why I was like,
So I figured out is I can, I'm going to have to use first names only. Yeah, first names. So like right now, I'm cutting the visual feed so I can take roll. And I'm going to be monitoring. I'll monitor it. Okay, this should be public live stream. Yep, it's live. Okay, it's restricted from G Suite. Let me sign in as me. $231 videos, 417 subscribers. Okay, good. So I'll check the stream health.
can I get to the restroom for me?
Yeah, sure. Okay. All right. So in order to avoid... Okay. Just turn the audio off there. Now it's a monitor. Okay. All right. So today we are going to start a new unit. But I do need to take the roll first. So I want to make sure I'm not sharing my screen with the world. And then I will take roll.
Is the Monomial, may I use the restroom?
Sure. Is Tyreek here?
But he'll probably be here.
Okay. Everybody else here? Mason?
No.
Christian? Everybody else is here on this list? Okay. Works for me. Okay. Let me make sure that nothing I'm going to show is going to... Good. All right. Okay, now the world is seeing what I'm showing here. There are some things that we need to keep at the front of our mind in terms of scheduling. And the first thing is that the STAR benchmark is in 2.5 weeks. It's not next Thursday, it's the following Thursday. Okay, so not this Thursday, not next Thursday, but the Thursday after that. Wait a minute. Yeah, so almost 3 weeks from now. 2 weeks and 3 days left until the benchmark. Remember that the benchmark this year will be given just like every other benchmark, where they section off the halls and you guys have an uninterrupted experience. Also, there are 57 days now until STAR and 71 days until summer vacation. Those are class days, okay? All right, let's take about 5 to 6 minutes. I want you to do these problems, please.
So what do we do after start this?
after the STAR test, I'll start preparing you for geometry. But I think the subtext of your question is, are things going to get easier? Yeah. Yes, they will. We really can slow way down and kind of do a couple things that we didn't get to do much of, like watch movies, because you understand, like, the time sensitive critical nature of the class will have been met at that point, and then for the remainder of the year, it's like 2 weeks. There's no real reason to punish you or push you guys to the max. Okay. So if you can do this hard push for me for the next couple of weeks, and then we'll have a break, and then we have a little bit more work, and then we have spring break, and then we have our big push, our big campaign to get to STAR, and then it's all over, guys. It's all over at that point.
Is that a 5 or an S on that T?
S, good question. It stands for supporting standard. When you do these warm-ups, just write one problem at a time and then do it, and then write the next problem and do it. That way, if you don't end up finishing, at least you did something. Some people spend the entire 5 minutes writing down everything, and they don't work any of the problems. Okay. 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 Now it's working. Now it's working. Now it's working. Sorry, what happened there was a call came in on my phone, and that I just learned shuts off. Hey, just give me a second here. I have to make a copy of this page, and then I'll put it where you can see it again. I need to title this page. No. Give me just a moment, please. So this will be my first period copy of this that I'll distribute to you guys when we're done. Also, since this is being live streamed, when it's over, when the live stream ends, you'll be able to watch this tonight if you want to like rewatch the class. Okay, so I'll start working them. I know you're still working on them, but I want to start showing solutions so we don't get behind. This is not a graded assignment, bless you. Just see how you do. So n times n is n squared minus 3n cubed plus 2n. When I say factor, what I mean is pull out the greatest common factor and set it to the left of the factored expression. So here's what that looks like. We can pull an m out of both terms inside the expression, and we have 6m minus 8 remaining. Down here in number 9, it just says simplify. So we're going to combine like terms. So my first step would be to gather those like terms. 4w squared and 15w squared are like terms. Plus w. Those can't be mixed. These two can be mixed or combined. So that would be 19w squared plus w. So this is kind of the reverse of factoring, or you're kind of simplifying something. Okay, on to number 20. This one can confuse people because you're distribute multiplying each term into the parentheses, but we do it all at once. Okay? So I'm taking 5 times 4. You have to match the term with the term in the parentheses that goes with it. X times x cubed, that would be x to the 4th. And then y times y is y squared. So it just becomes 20x to the 4th y squared. Okay, so this number 21 is just another way of asking you to do the same thing you did in number 20, only we have 2 parentheses now. It's exactly the same process. Negative 2 times 7, negative 14. A to the 4th times A, that's A to the 5th. C to the 5th times C to the 4th. You add the exponents, so it'd be C to the 9th. Okay. Number 22 is a little geometric problem. If you square the side length of a square, you'll have the total area of the square. So what you do is you take that side length, which is 6x cubed, and you square it. You have to apply the power rule for exponents here, which means you're going to distribute that exponent to each term inside the parentheses, and that includes the numbers. So this becomes 6 squared x to the, not 5th, x to the 6th, because when you're doing a power rule, you multiply the exponents. And then 6 squared is 36, x to the 6th. That's the answer. So that would be like inches cubed, or inches squared rather. Okay. In lessons like these, sometimes we have to write so quickly or move so fast and cover so much that if you didn't get everything, if you didn't get it all written down, just make some space on your page or just turn to the next page and refer back to this video tonight, or refer to the notes that you can access these notes in Microsoft OneNote and just get it later. Okay. Also want to make a note that on page 472 of the textbook, there's more on this topic, and these questions come from page 461. The reason I'm starting to refer to the textbook is because that is we're going to begin incorporating. Over the weekend, I sent out a poll asking people, what do you think of the paperless environment? And what came back to me was, we love it, but we want something to anchor that to in the physical world. So I have two options for you that I'll discuss at the end of the class. One of those options is go to the library and check out the textbook, right? That's where all of this is coming from. So if you're blown away by this, there's all those full explanations in the textbook. Option two, and this is the one I recommend, download the textbook to your phone. You just use your thumb or finger and swipe to the page you want to be at. You can navigate by table of contents or keyword. You can search the book. So you can even read, the book will read to you. So we'll talk about that toward the end. Okay, this gets into more of what we're going to learn today. This is be a new page in your book. Adding and subtracting polynomials. This is TEAC 10AS. Means it's a supporting standard. You'll very likely see a question like this on the star, but probably only one question, maybe two. Usually they only put one where you have to add polynomials together. Or subtract, like in this case. So I want to walk through this. It says two rectangles are shown below. What is the difference in their perimeters? The first thing I would do is find the perimeter of each figure and then subtract. So we'll kind of work this out. Here's our solution. This is perimeter of figure 1. The perimeter is just going to be the sum of all the lengths. And because it's a rectangle, we know that 3x plus 4 is reflected on the other side, and then x is reflected on top. And so here's how we can do that. Oops, sorry. We write 2, open parentheses, 3x plus 4, close parentheses, plus 2, open parentheses, x. And you just distribute. 2 times 3x is 6x. And 2 times 4 is 8, so plus 8. 6x plus 8 plus 2x. And now we combine like terms. So I can combine 6x and 2x to give 8x plus 8. Okay, so perimeter 2. Well, that's just going to be 2 times 2x squared plus 3x plus 6 plus 2 times x. Once again, it's just a process of distribution. 2 times 2x squared is 4x squared. 2 times 3x is plus 6x. And 2 times 6 is plus 12. And then plus 2x. combining like terms. We have 4x squared with no like term. So he gets to stay by himself. Plus 8x, that's right, plus 12. So these are our two perimeters right here. Here's perimeter 1. Here's perimeter 2. They want us to subtract the perimeters. I'm going to show two ways to do that. And you get to choose the way you like of the two different ways. One is like what I call the stacking method. It's going to look pretty similar. And to me, this is the more intuitive way. So that's why I'm showing it first. What you do is you take the bigger thing, 4x squared plus 8x plus 12, and then you subtract the littler thing, 8x plus 8. Uh-oh. I'm going to have to shut the computer down after this class and restart it because I can tell the memory is about to die on me. Whenever that ruler won't work, I know the memory's going down. Okay, so 4x squared has nothing to subtract from it, so it just becomes 4x squared again. And now here's how you do this. You say 8x minus 8x. What's that? 0. So you don't put anything. 12 minus 8? 4. So we do plus 4. It's very important to keep all these things lined up. And then you can write it more normally. So then we come down, right, 4x squared plus 4. So this is the difference in the perimeters. And this was method 1. Here's method 2. And again, you choose which one you like. So in method 2, it's all on one line. It's 4x squared plus 8x plus 12 minus open parentheses. And this is the key. You put the thing you're subtracting from the other thing in parentheses. 8x plus 8. Now you have to distribute that negative symbol. So I'm going to write 4x squared plus 8x plus 12 minus 8x minus 8. Nothing changed. It's the same. It's going to come out the same way. So when we start combining like terms now, we see we've got 4x squared. The two 8x's cancel out. And then you have 12 minus 8, which gives you plus 4. I don't know. Sometimes you'll need to do method 1, or you'll have the freedom to do method 1. Sometimes method 2. That's the method, by the way, that you'll see more in college is method 2, all happening on one line. They like to save lines in college. Okay. Now, don't start writing everything. Let's review this and let's talk about it before we just start copying down. You will need to copy this down, but there's too much to write where we would spend the next 20 minutes writing all that. Okay? You will have access to this document in full. Okay? I'll make it available to you as we get into OneNote, as we get that set up. I'll make it available to you, but I will also screenshot what we have here or make a PDF out of it and then share that document with you on Remind so you don't have to be taking pictures of the screen. Okay, so definitions. A constant. That would be anything that is not a variable. And I've just given some examples of what constants are. So when I say the word constant, I mean a number or something that becomes a number like pi. So pi is not a variable, it's a constant, but it's represented by a Greek letter.
On the third word, is this thing after the M and A or an O?
What do you mean?
Like, it says pricing in degrees of something. Is that an A or an O?
Oh, okay. Oh, so part C, degrees of monomials and polynomials. I should have read that out loud. Yeah. Monomial, good segue to our next line. A monomial is just a polynomial with one term. And so terms are things that are separated by like addition or subtraction. So even though there are all kinds of letters in these examples of monomials and even fractions, there's no plus or minus symbols anywhere. So they're considered monomials. A binomial, and that's why I'm highlighting the Greek or Roman, Greek or Latin prefix to go with the number that it is. Mono, mon, one. Bi means two. Binomial, two things. So here in binomial, we've got x plus 1, 2x squared plus 6, 9y minus 4x, 3xy minus 6z, and then even these weird fractions over there where they don't really look like binomials, but they are, because there's just two terms separated by an operator, either addition or subtraction. Division and multiplication, that does not make something a binomial. Okay, only addition and subtraction make things binomials. And then, as you might imagine, there's a trinomial, and that would be three unlike terms added or subtracted together. So again, I've got some examples. The intent is really for you, yes, write them down at some point, but I want you to look at it and get a grasp of what it means to be different. So in trinomial, we have x plus y minus z, negative 3x squared minus 2x plus 1, 6x squared y cubed plus 4x squared plus x. You see, there's three distinct terms, all separated by by addition or subtraction. Even the fraction over there, x minus y plus z over 5, it's a trinomial because there are three distinct, unlike terms separated by addition or subtraction. And then at the bottom there, all expressions with more than three terms should say are just called polynomials, not is just called. For what we're doing now, which is quadratics, you'll be dealing with binomials and trinomials. I'll throw a word out here about how to take notes in a class that's moving too fast for you to write everything down. Write down, if I was going to take notes on this section and I knew my professor was going to make them available to me later to complete them, I would just write down monomial, binomial, trinomial, polynomial. Boom, 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 boom. Jocelyn, are you okay? Why don't you go to the nurse? Go call your mom and go to the nurse. Okay, just go to the front office. Tell them you're not having a good situation. I hope you feel better. I'm sorry. We'll get you caught up, okay? And you'll have the video later. See, this is a good reason. If someone had to leave or couldn't be here, like Tyreek, he can watch this whole lecture later. And Jocelyn, when she feels better, she can catch up. As we're learning how to take notes here again, I want to reiterate the intention of your first run through in a lecture is not to take down every single thing the professor or teacher has written up there. You get the idea down in skeleton form, and then you go back and fill it in later, especially if your teacher is making the content available to you. Because I do have to move on right now. And I know that there are people who are not done writing, so just skip a whole page, okay, and go on to this section called degrees. And just keep in your mind that safety of knowing that, hey, I'm going to have all this available to me later as a PDF, as a OneNote, and as a live stream lecture. Okay, so write down degrees. I want you to write all this down. Monomial. Okay, so when we determine the degree of a polynomial, we have to first identify, is it a monomial or a polynomial? That's why those definitions were important. So for a monomial, you add all the variable exponents. So I've got some examples here that we're going to work together. Just want to compliment people on the good notes I'm seeing. It's beautiful notes. These flare pens are awesome. In fact, I'll get a bunch of them for the classroom because that's really cool. Alyssa, let's look at this first example here. Right here, x, y cubed z to the fourth. What is the degree of this monomial? And remember to count invisible exponents.
So we're adding them?
Add the orange number. What? 8. She said it, 8. And so the invisible exponent was a 1. And so, yeah, this would be degree 8. I guess I'll write it here. Good job, Allie. Well, no. Because I want to make sure that I explain this. So for the second example, we have to remember this note down here. You must simplify before finding the degree. Otherwise, it will be wrong. So let's first simplify this fraction, and then we'll find the degree. Okay, so I don't do anything with 4 to the 5th. But x squared divided by x is just x. And y divided by y is 1. So this just becomes 4 to the 5th x. Now, I don't want to call people out and try to trick people. The trick with this problem is you have to remember that we only add the exponents of variables. So this is, in fact, degree 1. Even though it says 4 to the 5th, that's a number. So that's a constant. 4 is a constant. Raised to the 5th power is still a constant. It's going to be 4 times 4 times 4 times 4 times 4. 4 times itself 5 times. The variable has an exponent of 1. So this is degree 1. Monomials are harder than polynomials, even though they look simpler. Because with polynomials, you just tell me what the highest exponent is, and that's the degree. So Nick, for this example, x squared plus 2, what is the degree of this polynomial? Yep, right here.
3.
So the only variable is x, and it has an exponent of 2, so this is degree 2. It's okay. This is also called a binomial. So this is a type of polynomial with two terms. We call it a binomial. Now over here, Nariah, what is the degree of this binomial here? M cubed plus 2 into the fourth. Yeah, that's right. So this is degree 4. Now, in this last one, we have to simplify first, so I'll help. I can cancel an a out of both these terms. So let me show what I mean. A squared divided by a is just a plus 2. And then a divided by a is 1, so that goes away. And then b cubed divided by b is b squared. So what's the degree of this one, Rolando? What's the degree of this simplified binomial right here? 2. Degree 2. And it's, again, you must simplify before finding the degree. Now, I'm breaking my own rule because what we should do is always write polynomials in descending order by degree. Constants always go at the end. So the way I wrote this up here is technically wrong, but I mean it is correct, but we want stylistically, I should say. I should have written, let me make this note here. I should write 2b squared plus a, because I want to write it in descending order by its the highest exponent comes first. I probably should have said by exponent. Well, whatever. Let me do a cross through here and say by exponent number. You get it though. It's the biggest exponent comes first. So let's work this problem together. We're just going to simplify this and then write it in descending order of exponent. First, I'm going to gather like terms if there are any. And I'm looking at this and there are none. So I'm just going to order them by the exponent. So that would be 5x cubed plus 3x squared. And then it's up to you if you do plus y or plus x. Well, I'm just going to do plus x plus y plus 4. So all you had to do in that one was just rewrite it in descending order. Now, I wasn't just choosing out of thin air on x plus y. Typically, you want to write if you have letters and you're trying to figure out what do I do, it makes sense to go x, y, z in that, or x plus y plus z instead of y plus z plus x or something. Just try to keep everything in sequence, in order, in some logical order for you. Oh, I'm sorry. Constant, yeah, numbers that are just by themselves, they always go at the end. Okay, guys, we're going to skip this for now because I think we have the idea. This is the final section, multiplying binomials. New page, yes. We're almost done. This is the last part, and I'll get to this other stuff later, tomorrow. You're doing great. Now, so we have two binomials here, 2x plus 3 and x plus 5. We want to multiply them together. You can't just do it the way that you probably, there's no like direct way to do it. You have to learn a new method. So there's 3 methods that I want to teach you. This first method is the distributive property method. We call it the horizontal method. So just kind of look at the logic of it. You multiply the 2x by x plus 5, see? And then you multiply the 3 by x plus 5. So if I multiply 2x plus 3 times x plus 5, I multiply 2x times x plus 5 plus 3 times x plus 5. You're kind of distribute multiplying each term of the first binomial by the entire second binomial. So let me show the answer. What would that be? 2x squared plus 10x plus 3x plus 15. And now you just combine like terms and simplify. Descending order by degree, or by exponent. 2x squared plus 13x plus 15. This is called a quadratic equation or expression. Okay, it's also called a trinomial. Not all quadratics are trinomials, and not all trinomials are quadratics, but this one's both. The reason it's called the quadratic is because it has a highest exponent of 2. If it had a high exponent of 3, we'd call it a cubic. If it had a high exponent of 4, we'd call it a quartic. If it had a high exponent of 5, we'd call it a quintic. If it had an high exponent of 1, we call it linear. So that's the order. Ready? Here's the exponent. High exponent 1, linear. Exponent 2, quadratic. Exponent 3, cubic. 4, quartic. 5, quintic. We'll get to that later. I'm just reading ahead. And notice the page number here. All right? Page 480 has all this stuff if you want to see this in depth. Now I'm going to show you the 2 most common methods of binomial expansion: FOIL and box. First, the FOIL method. This is something you need to memorize. I don't ask you to memorize much in this class, but this one you do. You need to know that FOIL stands for first, outer, inner, last. Say it back with me on 3. 1, 2, 3. First, outer, inner, last. Again, first, outer, inner, last. Nick, what's the I stand for?
The I. Inner.
Okay. See, we'll get there. Now let's do it. The first couple times you do this, it's going to seem hard. Then you'll do it in your head. You won't even write all this. Oh, it's kind of like a Punnett square. That's exactly right. It is the same exact thing. Good. It's a connection there to biology. So first we multiply the first terms. What's x times 3x, Alyssa? Squared. Now the outer. What's x times 4? Plus 4x. Make sure to put that plus sign. Now inner. Negative 2 times 3x. Justin, what's negative 2 times 3x? Negative 6x. Okay. And then finally, last, Rolando, what's negative 2 times 4? Negative 8. Now we combine like terms. These middle terms will always be combinable. Always. So now we have 3x squared minus, what is that, minus 2x? 4x minus 6x, and then minus 8. So this is a quadratic. See? Okay, we'll leave this one alone over here, this x plus 1, 2x plus 3, because I want to show you box method. Most students find box method the easier way, but I'll tell you that the way that you should learn it, you should learn both. That's what you should do. Because sometimes box will be easier, and FOIL is easier when there's two binomials. Box is easier when we get a little bit further along and it's a polynomial multiplied by a binomial. So let me show you box method. So write x plus 3 here, and then write x minus 4 like this, and make a little box. You guys will like this. It's kind of more visual. Now fill in the box. What's x times x?
Oh, I did this.
Mm-hmm. What's x times negative 4?
We did this in Miss Lynch's class with cross improvements.
Oh, okay. 3 times x is 3x. 3 times negative 4 is negative 12. So now just write it out in descending order by degree, by